The building of pipeline starts with respect to ETL only.
No, I mean, okay. So it depends, right? Like in how's your no, what kind of lucky team you're part of? I use the word lucky because if you're part of team where you are already getting a very clean structured data, you know the S3 path or AWS GCP path, then yes, it's I would say then you can directly start with ETL maybe, or else at least I was not lucky all the time. I got in a place where I just didn't know the source of data. I literally don't have any idea what is the data. Maybe that is sensor data, maybe it is some data, like CSV file, gzip, which I don't know. But then I need to pull the data, I need to do something about it, and then finally build a data pipeline. So deployment will come far in the future, but before that I need a strategy. We can go with that direction, but I'm not sure, do we want to go to that starting phase, or do we directly consider we have a data, we have some setup, and then we can directly jump on the deployment and CI/CD side?
I mean, data will be in different formats. So, and how can we set the things in right way? We start from basics from the stack activity part. So, this is
So Abhishek, when you're saying like you didn't get chance and you didn't get the data, luckily, like the structured data. The correct term is the structured data, if I'm not wrong, right?
Yeah.
So you said like it was not sure that it will be JSON, it will be CSV. So how exactly, at least source, what I have worked, and as per my understanding, always there is we get to know that what kind of data they're going to share. Is it either it is JSON, either it is CSV. It was also not confirmed by the source what kind of data they're going to share, or what exactly problem was in your case.
Personally, in my case, when I started a Kickstarter project, it was more like you talk to the vendors or the data sources, which can be, for example,
Absolutely.
Kafka queue, and then if it is Kafka queue, you have some schema manager in between. If there is a schema, you already understand how's that data look like and what is the format and type. But if it's, for example, plain setup of S3 bucket where you got lot of subdirectories and folders, and there is no documentation, no information, nothing at all, it is
Okay.
just a lot of data, and then you created a new team, you are part of that founding team where you need to build analytics, data science, machine learning product out of it. Then you are in step -1, you are not in zero, you are in step -1, where you really need to understand what are we building. Okay, we have some imagination that this data is all about customer data, analytics data, or some pricing model, something, mm, but that's what my intention was, like when I said I went
Okay.
with that.
Yeah. Yeah, otherwise we cannot build any model. If we're not going to be having any picture in the business, it's like a blindfold.
True.
So I also have a question about extracting data from several different files, such as, for example, if you have in the data source CSV files and JSON files and hierarchical files, buckets, Algo, and others. So you have multiple files for that. So to do that, to create an ETL pipeline, extract, transform. So before the phase of transforming the data, should create a schema to group all data from all these files. Create just a schema that works with two formats and we neglect the others.
I got your question, but Abhishek is also there. I guess let's
No,
let them drive this conversation.
no, I believe you can start because somehow my net got disconnected, so that is fine. We should move on. Like, please answer. Like, I will follow up in meanwhile. Please carry. Yeah, can.
I think I can
Yeah.
answer this question.
Yeah, please.
If I understand your question correctly, is how we can unify all the different types of data as well as the schemas of data coming from different sources, the column names. For example, one countries having different date formats, different. So there is some type of transformation we have to do and manually map sometimes the schemas.
So, if it is not too much, can you briefly tell about SQL Alchemy?
Okay, SQL Alchemy is an ORM tool where we can the schema modeling or the data modeling is done in SQL Alchemy as a special script. I use Python for scripting it, and whenever I make any column additions or data type changes or anything, I do it in that, and it creates a versioning on file basis. So if I change my column from name to first name, it creates a version and it updates the column. When I roll back it, it also rolls back it. It's kind of an what you call versioning tool for databases.
Okay.
Something
But
which is very high level. I didn't completely make it, but this is one.
But again, Abhishek, I guess for that licensing and all things are required,
It's
and
an
all
open
the
source.
business open source. Okay.
Okay, talking about versioning the databases, but since we all are working on big data, I will have a first question on how much data. So how much are you actually working on a transactional databases, large scale Postgres or SQL, and how much you are going to the NoSQL era, like distributed databases? Like what is the proportion? Because why I'm asking this question is, yeah, there is a possibility that your all transactions are happening in Postgres, but it doesn't mean you will do everything, all your deployment after that in Postgres itself. You will use Parquet or you will use Spark, and if lot of you are using ETL on Spark, I don't think databases are the best place. Like you will pull data in some other format. So what is the catch here? I really want to understand that first.
From my side, I currently the project which I work is like this. But in my experience, when I have a long, I use only object store with Delta. Like
Okay.
it solves most of the problem in object stores where I save it in Parquet, that is Delta format. And whenever I need it, whatever columns I need, I just pull it in my Spark and load it into the data warehouse, whichever columns I need. But the data warehouse is a problem where when a new column comes, the evaluation takes complexity, and which we do it only through change request. We don't use a CI/CD on the data warehouse because it's very complex to use a continuous integration and continuous deployment. If anyone have an experience in doing CI/CD on a typical Oracle data warehouse, please let me know how to do it. It will be useful.
You are saying CI/CD means database capturing, right?
Yes, database versioning and database capturing, all those things on a Oracle data warehouse, because it's easier to do it on an object store and on a smaller transactional database using SQL Alchemy. But when it comes to an large scale 50 terabyte, 100 terabyte data warehouses, and which is continuously used, it becomes, and I still don't use a NoSQL database here. So for analytics on the end layer, so that is one more thing. I am just on Elasticsearch part, but Elasticsearch already evolves schemas. When you add it, you can add a new column pretty easily.
Let's try to collect and summarize on this. First thing is, as you said about the text side, I will just suggest one word, Bayesian. We won't go in detail to that, but try to see that model of Bayesian. Like CI/CD over Q engine distributed log is now getting, and it has many connectors. So maybe it will help. I didn't use it Oracle, so I'm not sure with Oracle it is perfect or not. But Bayesian is one of them where you can do database capturing on scale. Now, on the second point of our actual question on like best practices on data pipelines deployment, CI/CD, we are already there, so it's a good thing that we are very close. How, in general, if I'm just trying to replicate what usually the data setup looks like, and you tell me that if you think you agree or disagree to that. So we have data somewhere, it can be anywhere. That data either come on the queue or it enters in your system in a particular storage. The storage area is usually on cloud or your on premises HDFS or somewhere. So it's finally a distributed storage just to ensure safety and single source of truth. Once this data get in, then our jobs come. In our job, let's assume that all unzipping, cleaning the data is done, because that's the data quality part, and that's a huge conversation we end up just last time and we never managed to finish. So that's why I'm intentionally skipping that part. And then the data is ready. You and then comes the data pipeline. This is a huge thing. When this question was added, I was bit concerned about this. Like, what is the definition of data pipeline here? ETL, DBT, using Spark, transforming data to one point to another point, or building a feature pool. So in general, what do you say is data pipeline?
I'm answering it.
Yeah.
It is a program or a script which takes data from one point to and put it in another point. It can be anything from one file, just picking up, copying it, and pasting it in another is also moving a data. So it's also considered data pipeline according to me.
Okay. Does anyone disagree, or any other view? Not disagreeing, but any other view on data pipelines?
Yeah,
Uh,
say for example, I have defined a YAML file wherein I defined the Kafka, Spark streaming, and Spark. So my data is having some source. I'm pulling with Spark, and I'm loading into Kafka. Through Kafka, I'm loading into NoSQL database like Cassandra. So I'll write a code using a Cassandra connector and using Spark code. I'll load the data into Cassandra database. So this is it's a data pipeline where the data flows from one end to another end, where I do the processing in Spark, and those processed data I'm loading into the Cassandra database using the Cassandra connector. This we define it as a data pipeline.
okay.
I would
So
add one
maybe,
point to the
maybe, I,
pipeline.
maybe I can give another definition. Data pipeline for sure is sequence of steps where the data is extracting, transforming, and loading. That's simple.
Okay.
I would add one point. It's a pipeline or a term is the script which does the same thing again and again without any flaws. Because if I am copying it from one starting point to a destination, it should, if I run it again, it should work with the same intention. It shouldn't change. The pipeline shouldn't change direction, or it shouldn't have bottlenecks.
Okay. So
It should do the intended job.
It's
as-
like a no side effect function. So
Yes.
it's an immutable no side effect function. I saw Anmol was saying and Hitesh was trying to add. Did you have any other opinion on this? You would like to add?
No, I was having a very simplistic view. Like pipeline was just like a water pipeline. The term is just a means of. Someone also said that it's just a means of transferring data from one place to the other, from point A to point B. Could be source or sink. These can be interchangeable, or can be real time also. Let's say when you switch off the tap once in a while, it's batch processing to be seen at this way, and real time processing when you have to go through this pipeline again and again 24/7. So it's a very simplistic view, and all of this technology, be it Azure data pipeline or Amazon or anything Spark, ETL, it just comes on top to facilitate that process.
Okay. Any other view?
No, actually, my point was briefly explained by Ariel. So that's what my so it's a set of operation that needs to be performed on my data, whatever data is coming in, and whatever if the same data is passed again, so it should have the same effect. That's what the existing is. So that's what you said, the function with no side effects. That's really what I said.
Okay.
Right.
So
one more point is, for a data engineer role, the work starts with the data pipeline at the beginning and ends with at the endpoint of the data pipeline, the data engineer role. So that loading the data and processing the data, and again loading the data, process data into the target. So that's how the data engineer role. That's what I mean.
Okay, good. So unless we don't have any other objection and nobody raise it, so I will conclude that data pipeline in a very layman term, moving data from one point to another point in a different transform way. It can be same way, it can be transform way, it doesn't matter. You move data from A to a point B, and that data can be transformed in between. That's it, what our data pipeline is all about. Now we say we want to deploy it. Now when you move to point A to, for example, you want to move to point A to C. So first you go to A to B and then you go to B to C. So you already have a deployment here. Why? You can have a microservices based kind of setup where you responsibility is put your data to the B and you leave. Or else you have a inside B you have a two kind of pipeline. One goes to analytics, one goes to machine learning. So those two actually branch out and have a very different transformation. So now you have C1 and C2. So from B you have a C1 and C2. So that way you have the concept which we all aware of maybe, or if not let me know, it is DAG. So we create finally an usually acyclic graph. I use the word usually, but it's kind of that we create, and then we actually create branch out, and we keep on creating this kind of pipelines where we transform the data by using different technology. So here I really think it doesn't matter which technology we use. It can be Spark, it can be SQL based DBT, Python, it doesn't matter. When it comes to deploy, it means we want consistency, availability. So it's a cap. We want both of them. We really want it to be available by X point of time in the morning or maybe every half an hour, and the data should be consistent. So all the transformation what we did, it should exactly what my downstream is imagining. That is where we say we have so much emphasis on deployment. We want to do it deploy properly. Am I correct on this preface?
Yeah.
Okay. Now
maybe about
yeah,
about branching, so we can add demi path. So where data pipeline doesn't go neither to analytics, neither to data machine learning. Can use empty path.
Yeah, we can put in queue, then we don't care, right? So for example, we dump that in Kafka queue, all the output, and then I don't care whoever consumes. I have a schema there, and whoever wants to read in what format, I don't care. So that is another can be a path. But objective is, yeah, we finally put on the path. Now let's come on the basic part on deployment. How do you really want to deploy? Like in our case, there are multiple ways of deploying. So when it comes to deployment, we use workflow engines. So we tried Airflow, obviously, and then I tried Argo because I'm in Kubernetes ecosystem, so it was pretty easy. So how it was happening is, this pipeline was written usually on Pandas, some in Spark, and then and in Spark, some of them are actually SQL. Like data scientists actually wrote Spark SQL code. So it's a SQL in the behind the scene, but it's a package inside a Python library or PySpark package, and it runs. Then we create tasks. So in a not a definition. So we have many transformations. So one is done by one other team member. I did some of the pipeline. So we create multiple branches, and we have a different compute engine for all this batch. So I wrote PySpark job, so I need a PySpark cluster. One of the member needs a Python cluster with a fancy makefile he created. Another needs a SQL engine because he's querying from data warehouse, and then he's appending something, and he's generating and pushing the output to the blob storage. So this can be three or multiple hybrid way of generating it. So for us, we just created any workflow engine. It really doesn't matter it is Airflow or Kubeflow or Prefect or Daxter, but it's a engine. So we push the code. we have a test cases suite. It runs. It generates the Docker container. On the Docker container, we then have a deployment. Two ways of deployment. We have a manual deployment where we manually go and run our workflow engine one after one or in a parallel way run, or we have an automated every day morning 8 a.m. or night 9:30 p.m. start. So as a scheduler, as a cron job, and it start and it gets an output. And finally, in the morning, when we know our result must be reached by 9 a.m., for example, we have a sanity check, which will go and check all the output for trying to find any problem or trying to be a developer's advocate. So that's the devil's advocate, sorry, to go and try to find is there any problem in the output or not. That we will assume as a deployment. I will pause here. What are others' view on this?
I have one question. So do you have different connectors installed, or you use an API mode of connection, general API? Because you said you are using different types of PySpark, SQL engine, and Python, simple Python.
So we are using all these things we are doing in Kubernetes. So for us, everything is pods, and we just create task. And for example, in Airflow, you create a task, right? So that particular task can be anything. One can be Python operator, one can be Trino operator, another can be PySpark operator. So it depends on what is the container you created and what kind of virtual environment you want to run. So that's how
okay, my question is because, for example, the PySpark job needs to read from some source the data and write it to some target. So it is all the you have an unified storage to execute all these PySpark and everything, or it's a different types of storages. Each and every transformation or the tasks store the data in a different location or in the same location.
Oh no, so it is all definitely purely append mode only, and everything is had a very abstract as a location. So you won't find one location to it. So of course there is so many multiple writings. So all of them has a separate, you can say, sub directories inside S3 storage, and it was appending there. So none of them are concurrently writing in the same location. No, we are not doing that.
So in this case, it's pretty easy to do deployments. If you change any PySpark topic, you just deploy that PySpark topic alone, and it works independently. I feel like it's every transformation or every task is decoupled from each other because you are storing every task's output in a different location, and maybe you are versionizing each and every task's data storages also. So it should work.
So I intentionally avoided many things into this. Let's say this way, that I avoided talking about Iceberg or Delta Lake. Avoided talking about merging this job and tagging and flagging all the behavior, because I'm not sure all because here we as a simple setup, I just kept it as an abstraction. There are many, you can say, mature settings you can do, as you can imagine, as you already hinted, where you need to converge this. But one objective is clear, which you use. Our most of the transformation is decoupled. You want a coupling, you create your own task and just create a new pipeline out of it. But when you think about a pipeline, if you just decouple, it is very easy to manage by different groups or teams. So that is, and when it comes to read, everything is kind of a distributed logging. So just go to the topic and read it. I don't care. So for me, I will just push my output in this particular topic or location, go and read, but don't write anything to that. Even you don't even have your application won't even have authentication to write over there. So that way we
so
control
each and
everything.
every task has its own destination, has its own directory, and any other task cannot write it to its location.
No, it can't. It depends. You need to flag the task. You are actually flagging the task with the authentication. But I will, Hari, I will say we can discuss about it later, because I don't want others to get carried away with understanding why we are talking. So, sorry, Hari, if you, I mean, I understand what you are saying, but I just intentionally abstracted it. So, if we go back to the abstraction, what others think about it? Like that is one way of deployment. I won't say it is right or wrong. I would like to know others' opinion, how others are doing it.
Um, Actually, what we do is sort of a different. So actually, what we used to do is sort of different thing. So it's basically like we are using Kafka as a trigger to a job. That's what we're using. So basically, one job completes and it puts a message into Kafka topic. Then it triggers another job. So that is one way. So the other way was we were storing the details in a file. Okay, and it is uh, run on the cron, the sort of cron thing is scheduled. After some time, what it will do, it will just pick up, read that file, and see, okay, so what all things have changed, and then query that data from the source, and then go ahead. That's how we go about it. The way you're saying is that that can also be a good way. So it's basically like you have created a Python, no, not Python, Kubernetes deployment, and you have different pod definitions there, and those are running in parallel. So that is also easy way to do it.
Yeah, can we pull NiFi into the picture if possible for building data pipeline? It may be odd question, but I'm sorry, I'm trying to get the information from NiFi. And NiFi.
So Abhishek. So he's saying that can we use we use NiFi. So NiFi is another way of orchestrating your pipeline. So it's basically like it's not a DAG based thing, but it's sort of same way of using if you are using Airflow or any other Dragster or Prefect, any other tools, which basically gives you a pipeline visibility.
Which is more commonly used comparing to NiFi and Airflow?
As of now, I would argue Airflow. I may be wrong, but I personally feel Airflow is.
What is the major difference between both of it? Because
I will just jump in, but NiFi itself is a completely an ETL tool, but Airflow doesn't do transformation. Airflow is just an orchestrator, but NiFi can do more than Airflow. So you cannot directly compare both according to me. I might be wrong, but just saying it. But NiFi is a complete ETL tool. You can do a lot of things with NiFi when compared to Airflow.
Okay, I don't have too much experience on NiFi, but if it is true, then yeah, you can't compare. It is like the NiFi seems to me kind of an ecosystem of data engineering where you can do many things and then you can schedule the jobs. But Airflow is designed, or any workflow manager is designed to replace cron, like complicated cron structure where you need to do repetitive job, you need to put a logging, you want to abstract away from all the pipeline management by themselves, and you say any team go and create your own pipeline out of this, I don't care. So in that sense, Airflow is good when you have a very decoupling between your workflow manager and your actual source code or your execution engine. And MyFi, unfortunately I don't have any information beyond it. Any other point with deployment with this? Like, then if I ask the community, like, what is the recommended way to deploy data engineering? So that was the question. Like, how do you want to deploy data engineering pipelines?
So it completely depends on the SLAs and what are the funds you're using. Like suppose if I'm consuming some data from a streaming source, then it's expected to have all the downstream to be a streaming stream, and my pipeline should be a bunch of streams which are performing certain transformations. So, like, let's suppose your data is generated from some IoT device, and from that IoT device, the data might be transferred to the MQTT broker to a Kafka or any other streaming pipeline or like Pulsar. Then from there, you have certain job which is reading the data from there, and then it is passing on data another stream processing engine. It may be Spark, Flink, or standalone Java application written on the top of Kafka, and then this complete pipeline is completed, and then it is the last streaming job, which most probably will writing into some data storage so that it can be accessed at the later stage. Or it can be the case that in between that can be written into multiple data sources. The other way is that suppose you are a batch based thing, so then it's like sometimes the cron job is more than enough if you are running a job on a nightly basis. You do not need the complexity of having the airflow because in some of the cases, because your data volume is not that big, and your one job or one job and or two jobs are more than enough to do your work. Then it based on the as the complexity increases, then you need to introduce tools like Airflow and other stuff, because that's when the what you can say, the main advantage of using workflow management tools comes in when you have the variety of sources to connect, and we have variety of sources downstream destinations where you want to send the data.
I agree. Yeah, Aryan. Yeah.
My version of pipeline deployment is each and every pipeline should be its own microservices. So that should be like, for example, if I have a pipeline which picks up data from three sources and loads into one source, it should be a complete microservice. It can have its own Docker image in it. For example, I decided to use PySpark. I built it as a service with connectors to connect to three different sources and write it into one target. It can be an object store, so it's easier. So it stays individualistic. So when I do an update on that particular pipeline, I update that microservice and only. And this pipeline can be reused. If it is having a three connector, you just give which are all the connectors ABC, and the details for the connector, it can be reused. This will be helpful. My version can be helpful in different deployment environments like production, staging, and everything, because you just change the parameters to the connectors, username, passwords, and those type of secrets, and it will work seamlessly according to me. I have tried building these in one of the cases and it's working fine, but this is very difficult to build in a big data ecosystem, because we will have lot of pipelines and the maintenance becomes very difficult when you have a lot of microservice systems. So
Yeah.
that's the
So I think that's where the buzzword of data mesh came up, right? Where we
yes,
say the
yeah,
microservices are
Martin
data.
Flowers data mesh is
Yeah.
kind of
Yeah.
this.
That's a very interesting two side of it. One is so in data engineering, at least in data pipelines, I personally felt if you could decouple everything, which I was just saying, and going in the microservices approach, it is good. It is easy to manage, but it is complicated engineering. I mean, it depends. Like, you still need a global view. You still need to see which job failed, who is actually monitoring, who is actually tracking, who is putting the log, and then the other problem is, okay, I may be wrong, but when it comes to microservices, the assumption is short running jobs, or at least on the APIs. But in data engineering, at least I have worked with some of the batch processing, which takes, with too much optimization, it takes 6 to 8 hours. So
yeah, it is there. This problem I am currently facing where the jobs run a long time. So that's why I didn't want to use the word microservices, because it's an API based calls and everything. Where we consider this to be a microservice, but it is true, it is a pure pipeline which runs on its own Docker images type of things. That's it.
So we have a question immediately pop up now. So what is microservices? Atul just yeah, Hitesh, go on.
If you want, I can. So microservice is just a buzzword, I would say. So microservice is an application which is a standalone application, and it does micro task, a small task. That suppose you have some API call and it reads from some database and returns you the result of that API. It may be a post, or so that is the basic definition of microservice. But a microservice can be the way you're talking about it, so it can become really big as well. So it can act as a abstraction to whatever you're doing. So for example, so all of the AWS services, they are microservices. So whatever you're using, so whatever API that you're calling is basically another microservice you're calling it, and it is doing some stuff for you. So let's suppose you have an S3 upload object. Okay, so you're passing your data to it, and then it's basically giving you something. So that's what you can call it as a microservice. So yeah, in broader terms.
So yeah, thanks for this. So yeah, so Atul, I hope you understand, but I will still say just read about microservices a bit, because it is eventually become a part of data engineering and data science as well. So we all are playing with APIs now, and this is where it is pretty easy to work with.
Yeah. So actually, I'd like to add a point to what Hariharan was saying. So this way, we did this for our project, and it came to bite us back. I'll tell you a story if all it is all of you. So basically, we were working. Basically, we have IoT sensors which are sending the data at all the time, and some of the things needs to be performed. So we created the bunch of streams, basically a Spark streams which are doing their stuff, and one stream is passing data to other stream, and so on is going. So it works seamlessly if you have the data constantly flowing in and you do not have spikes. So what we did is in the same architecture, we introduced a stream which takes an input from the user, and it is sort of a reverse ETL stream. So if you are aware of the reverse ETL stuff, so let's suppose, uh, so when our data scientists were going through the data and they found some mistake in the data, or they want to change some data, or let's suppose, so it was basically a signal data, so they were marking this data okay, and they want to tag something on the data, or they want to have certain operations perform on it. Okay, so it was working fine initially. So but what happens, so we are showing the data in form of aggregate. So when it comes to aggregate, the thing is, we have 10 kHz data, and 1 year aggregate can have the number of points being impacted like in billion, and billion is not 1 billion, so it would be hundreds of billion. And so for the user to say that okay, so I'm just marking 1 point, and it is taking almost 1 hour to have my request complete. So that's what create an issue. So we should be aware of when to do a microservice based approach and when not to use it. That's what
We can still
you
keep
need
it
to.
as a pipeline and run it in a long term on a trigger
Yeah,
basis,
so
right?
that's what we end up doing it. Uh, but first, when you invest so much time and deploy something, so then first you need to justify. Okay, we have invested so much time, so it is working. It is not working. So you'll try to optimize it, and then after some time you'll be like, no, it is
I
not
also
working.
use it as a buzzword, Hitesh.
Yeah, yeah,
Microservices
yeah,
is
yeah.
just a buzzword
So
to
yeah, so
please
that's what
the
I'm saying.
application developers, not the
Yeah,
ETL data engineers.
yeah, yeah.
Okay, so good. So at least we got two version of deployment. One is essentially workflow management. No, multiple versions. One is like if you have a less number of jobs, you can simply use a small cron job, or even any normal ecosystem where you can just deploy. Like if you are having 2-3 jobs, why you bother about big ecosystem like Airflow and all these things? If you have a very decoupled infrastructure and you have a very solid engineering team in between, yeah, go ahead with microservices. uh, if you have that kind of engineering resources which you can add, and you have a very solid infrastructure setup, microservices is good. And finally, workflow management side, where you have too many cross join on the product side, and you then investing on workflow managers like Prefer, Daxter, Airflow is not actually a bad thing. But there is an additional question to that: SQL data management. I mean, it is a this question is a bit tricky because not everyone here may be aware or using DBT. So that's the first official foundation pipeline of SQL kind of pipelining. But consider you are not doing it, how you are actually working and managing this SQL pipelines, because I'm pretty sure I have done it. There are many pipelines like that. So with stored procedure, triggers, there's many ways to do it. But what others are doing? I'm very curious to know about this.
I use Informatica
Okay.
or Talent or some tool-based SQL-based tool, ETL managers, and we can partially use Spark SQL in this case to do it, but It's a two-way thing. You extract from SQL and again do a transformation and load it. I will instead go to stored procedure managers and call it using an application and load it, when, or trigger it using some way. But as far as in a big organizations like I work, we use a proprietary tool like Informatica or Talent and avoid these problems of maintenance because it's easy to maintain, monitor, and those type of advantages comes in Informatica.
Okay. So yeah, there is Azkaban, Informatica, Talent, Spark SQL. Yeah, that is a way. I won't deny it. But when it comes to SQL management, I will highly recommend try DBT. I will try to give a demo of DBT pipeline in upcoming our meetings. But it's actually a pretty solid ecosystem to do the SQL management. But there's a thin line between doing SQL pipeline data management and SQL. What I meant is one of some of the things which I have seen doing and they did as well. I just run the SQL because it is easy and preferred by many in a declarative and imperative sense. But they in the end the output is written as Hive or Parquet. Then again I read it back in the next. Then again the SQL magic did. Then again write it back. So that is another one way which I will say don't do it. And it's not good. But yeah, sometimes when you want simplicity, you do this trade-off that do you really want to bother on having this kind of ecosystem or just write SQL, write, read one after one, then end it. That's one script I want to run. So that is I did. It's my folly maybe, but that is another way. Point comments on
Yeah,
this?
so yeah, so the way you're saying, so it brings me back to the point when why Spark was introduced initially. So it was basically doing it was reading and writing and again. So that point come to my mind. But what I have seen, so actually, fortunately or unfortunately, I would say I have not worked with the SQL data much. So most of my time have been with the NoSQL databases or the object storage. But what I have seen from what my friends do, so some of the friends, what they do is they basically use Looker. So they have the tables which are being loaded there, and they use Looker for everything, almost everything. They have a table, and there are some concept I have not recalled the name exactly, uh, where they are using that only to create another table for refresh and everything. So basically, the complete data engineering thing is on the Looker.
Yeah, BigQuery
You
is
can
pretty
do
well.
That's what I
generalized views also, right? In this case of doing it in
Yeah, so it's sort of materialized views only. So they have something called look ML, so which is sort of a modified version of SQL, and it gives you some data modeling stuff. So whenever I meet him, so he's always like, "Oh, you should try this. Like, this is really great," and all the stuff. But I have not got a chance to work on it. And also the Looker is not available in open source, so I cannot look into that. What is it exactly? And license is
but
$2,000.
Looker
I
is
cannot have it my personal one.
but Looker is mostly an analytical tool like Power BI or it's a Google version of
No,
analytical
no, that's
tool.
what. So that's what the common notion about it is. But it has lot of stuff. So even for the machine learning, so they have certain things built in. They do not uh, uh, go into the your complete Google ecosystem. So since they were the different company from the Google itself, and it was acquired later by Google,
Yes.
so it had a lot of stuff inbuilt with them earlier on.
I go ahead, Chanik. Yeah.
Yeah, I mean, I got a chance to migrate from legacy SaaS ecosystem that was written in SQL. I mean, it connects to Hive. So basically, it's like HQL, huge, SQL files. So we wanted to migrate that to something else. I mean, we wanted to get rid out of SaaS ecosystem. So what we have done is we created a Spark SQL framework. So all the HQL files will be taken as an input, and we are creating a data frames. So the final data frames will be persisted again to Hive, and like Abhishek said, we were using Parquet as a storage. So I mean, the how we have done is, I mean, it's not so fancy, but we created a Gradle based project. So the Spark SQL, whatever the SQL files will be taken as an input to the jar file, and it finally persists to Hive tables. The only problem we faced in this process was creation of the SQL files. We had some problems with spaces or the character line endings. So that has been taken care of after a couple of releases, but it was running smoothly. I mean, at least we had this kind of problem. I mean, it's very difficult rather to rewrite your Spark APIs. So we decided to reuse the SQL file, but rather send that as an input to the jar that has been created. So it was running smooth. So I mean, at least the business is happy. For at least we have migrated something like 15 jobs from SQL, pure SQL to Spark SQL based approach. For the newer change, for the version changes and all, so it still goes into the same fashion, like create a branch and make changes, and still the SQL files will be, changed. I mean, that's how for those particular jobs we are trying to, add more features. Just wanted to.
Thanks for your points. So I believe when it comes to the looker, I totally think it is kind of close to writing pipeline using BigQuery. So that is a common thing. Like if you are SQL ninjas, you can actually write pipelines on the BigQuery. I mean, not DBT is not the only thing, but that can be done. But when it comes to the pipeline best practices, because our point was best practices on that, I will still say try it for tools. Informatica is good, DBT is good, but the biggest problem is read and write, like saving CPUs, saving IOs, and not having a polluted storage. So in blob store, the one of the key element is we pollute a lot. We keep on writing things thinking it is cheap, and then it sometimes it get crazy to understand where you write what and what is this directories are doing. So that is what it is being I would say it is great if you avoid that gray area, because that is a gray area and that can do a lot of other damages if you think. And finally, after talk discussion with you all, I have a theory. Yeah. Because Chanuka has put a point of not being fancy or infancy. For me, what works is the most fanciest thing, because there is many time it doesn't even survive for that long. Some pipeline I built, imagine it will go for 3 years, 5 years, but I have changed entirely that in 6 months because of some other use cases, or I find a more better way to do that thing. For me, if there is a foundation, that's fine, then I will build on top of that, or else I will do the least amount of work to achieve the max. So if it is a pipeline, fine, I will write anything in Databricks as well, and I will put a Databricks job. If it is in Kubernetes, fine, then I will write a script. But minimalistic is the way I go, but I won't say that is the only way. What others do when it comes to do this deployment? Do you go with full-fledged, very solid foundation, or you just do whatever it is coming and then just get over it?
No, I mean for me, we just start with little, whatever the infrastructure what we have, and increase along. I mean, the add up more features along. So for me, if it works, like you said, whatever that works, we'll just go with it. But if we have engineering capacity, we will try to make it more modern. But that's not mandatory. I mean, at least in the most of the situations where I worked.
Others?
My
Yeah.
main one concern when I build a pipeline is reliability and monitoring of that whatever I run. What is the reliability whenever at whatever time it runs? So I try to add just a logging feature or in whatever I create, and as well as what you call a failure trigger if anything fails. So logging is the main thing which I added into it, and also some type of data quality checks into it by default, like the number of input rows and output rows. I write them in the logs itself when I create them to have a count and whether it is expected is coming or not in the logs when I check. So this is the added fancy things I added in a pipeline. But other than that, I try to keep it as simple as possible. But when I also ask the requirement to the main architect council is there because they normally think in very long term to run the project for 10 to 20 years in the company where I work. So they ask an explicit logging system where the data is stored for a longer term, the logging system. So these things added complexity, and the development of a simple pipeline becomes a huge time. But this is apart. But if it is for a normal thing, just create with a logging system.
So for me, it's always about function over everything. So if my main task is done between the given time frame, and I try to include logging in everything. So logging is there always, but the additional thing like the count checks and everything, I don't add it at first. Once I'm developing, it is there, but I remove those things because most of the time those sort of stuff close my pipeline, and I try to avoid that. And try to derive that. So mostly I have worked on Spark only, so I try to derive that from the Spark job, what is called for job matrix. So whatever it is using for the DAG. So basically, keep that job running for a certain time, and then in the test environment, then I come to know, okay, so these are the number of inputs that I can see in my this stage, and from this stage to this stage, it is coming to this one. Then I come up from there. So basically, I use that to derive my account. Uh, that is how I go about it. But it's always about the function over everything. So just like Abhishek said that my pipeline can look in one way in one environment and completely different in other way. So yeah, so uh, that is the thing. So basically, from where the data is coming in and where I'm reading it, or where I'm processing it, so it depends on that completely. There is no rule of thumb for that, and I do not believe in the architects which think of the 20 years, because from what I believe in, because there is no guarantee of the company surviving next 5 years. So we are not see it like that. Okay, so I do not think about that long term. I think about, okay, so for the next 6 months, do I need to do anything special for it? I'll take care of it. More than that, I do not care, because I know in the next year I'm going almost going to rewrite that thing in some other way. Or if working fine, then it's all right.
Cool. Thanks.
Hitesh, I worked on a pipeline which I don't. Someone created it 10 years ago in Informatica mostly, but it is. I work for Volkswagen, so there they have monolithic systems from very olden days, and it's really that it take things go slow, and also they think on more on reliability than the fastness of deployments and fastness of taking things to the market. That's what I miss with the startup culture and the new things and new companies. But I have posted a question in the chat because I find it curious for us data engineers. Do we ask this question before we build something? What is the use case of this pipeline or the data which we take it to, or intermediate systems, or else to an end system? Because this question I'm asking because Sadili asked that if hundreds of columns gets added in a source system which we read. I want to know if even millions of columns gets added in a source system, whether it's going to get used in the end is what will be my first question to a requirement. If it is not going to get used, it's not worth to invest our time in building that pipeline.
It really depends on your consumer. So for example, if my consumer is data science team and my job is to do some basic transformations on some columns, and then rest of the columns they take it, enrich it, try to find some insights on it, and then they come back and say, okay, ABC, can you join these two columns as well, or this 510 columns as well? Because sometimes this thing happen and you evolve, you really don't know. Or my job is to serve analytics business teams, business functions, where I clean all these columns and they finally do query and find some business analytics on this or BI on it. Then again, I can't control or they can't anticipate what they really need. I just need to deliver them that these are the columns suddenly incoming if it fit the contract of my schema, and this is the new setup. You have more new information of the column. This is a very common thing on sensor data as well. Like suddenly you started adding a new sensor on you, like in I worked briefly on the autonomous driving, and they always added a new sensor and new things,
Yes.
and you suddenly got a new, and there is one team who wants that data, and as a data engineer we sit in between. Software engineers, data scientists, and you are in between, you're like a sandwich, and it doesn't matter what contracts break. Sometimes you are in a situation that you still need to deliver that data, and for me, want to know. I know many things, but it doesn't mean I have 200% complete picture that how it will be used in the net. That is personally my opinion. I would like to know others.
So as Abhijit pointed out, so adding of 200 columns is a common thing if you are dealing with the sensor data. So there is one way to it is basically if it is a sensor data and it is basically a new center being added. So what we used to do in our case, it used to happen. So in one night, our sensor can go from 400 to 4,000. So it can happen anytime. So what we used to do, we normally created a common schema, which basically took, okay, so we have the sensor name in the column and the value, and then we have the sensor name status, and then we have a value for it. So what we used to do, we created from there, we created another thing. So it's basically like sensor name equal to this, and sensor value is this thing, sensor status is this thing. So basically, whatever data we are getting, we used to transpose that data into that format, and then we can use it. That is one way, and I don't think there is any other case in which you will have 200 new columns coming in, because in most of the cases the number of columns are limited to 40 or 50, and maybe one or two columns is being added sometimes. Not that drastic change of number of columns happens in almost in any scenario I have heard of. So I might be wrong, but it's most probably in sensor based data or some machine based data. This thing happens.
So normally you consider the schema added columns based on in the design phase itself, right? You will start designing the system that we anticipate more number of columns or any number of columns can get added in the later stage. So we will design the system in this assumption only.
It
to start
depends
designing.
on the application, right? Like if you are building some fixed schema based modeling like a streaming engine or somewhere, and you know the source, you have a control to the source. The source is your own some hardware or some software business cases. You know these are the columns you're always going to get, and then you can create it, and you can create this protocol buffer as a layer in between to serialize and deserialize, because then you save cost, and then you never allowed a blast of column, because then you lose lot of latency and throughput, and huge data means cost. So I won't do that. Then I know the contract. I know if you sending me new column, something is wrong, my pipeline won't accept it. So that is one way, one kind of application. And another kind of application is just what we discussed, transformations. So I don't care, I just care these are the foundational thing I need to do. After that, maybe other business cares about it. So that is two version of me thinking about it. But yeah.
I am sorry. There are a lot of new joiners, or what you call beginners in the call. So I think we made the call to an what you call design phase and designing topic. So I'm sorry about it if we talked about it. So
That is good. You are right. So it happens. I mean, we had a topic of three. We end up only discussing one, and I'm sure we can't finish it today. So can
Yeah. Actually, I mean, when the deployment point is concerned, for example, if I want to use Kubernetes as a deployment thing, because I'm completely new to Kubernetes, I would like to practically understand the Kubernetes, how to do that one. Is there any scope for a session on it?
Yes, I have a plan to take a session only on basics on starting with Kubernetes. But yeah, there is it's a huge.
Docker and Kubernetes
Yeah,
both.
Docker. I will just try to go in the very basic, but yeah, we will go with that. Chanukya,
Okay.
you have a question? Yeah.
Yeah, I wanted to understand how you are you guys are creating a logging mechanism to the data pipelines and how it you have different use cases and different organizations create their own shift, right? So it would be nice to know what how the logging is happening and how important is logging is. That's something we all understand. Yeah, that's the point.
Log4j. But I don't know what all you guys did in the last month with the Log4j applications. But
Yeah.
most of the tools, Spark comes with Log4j. We can use Log4j in it.
Yeah.
But naturally, Informatica or any other tool bases has their own logging systems in it. And good with AWS is you have inbuilt logging systems for the Glue as well as EMR uses Log4j, I guess. So this is the basic. You just add the comments when you are building the pipelines programmatically where you want the log points, what you want to log in your system.
I will stop you, Hari. There, I will interrupt. Sorry.
Mm.
Logging is fine. That is one problem. What to log will be my curiosity. What do you log?
Yeah, that's the thing, right? For me, I log whenever I am raising some exceptions or whenever I am creating some actions. Some changes to the data frame, and when it gets when it shifts a major point from raw to something else. Like if there is a huge transformation, I'll make some changes to that. Add some. Of course, that I am doing it, but I'm storing it on Log4j, and I'm also storing it again in another database, basically for verification and validation purposes. So, thing is, Log4j data is not being able to access for everybody because of the infra issues. The access issues. So that's why we are persisting again a separate log to for everybody to access. That's my problem. I wanted to understand some better how it's happening.
So that is one good way of logging, of understanding application. There is another logging which I am a bit involved. It is performance based logging, which we also known as observability monitoring. So why I added this too in data engineering, sometime I'm more interested on why my job suddenly taking 2 hours, which is just supposed to finish in 15 minutes. Yeah, scaling is fine. I scale it, so it finally managed to finish it. So do you all uh, consider that as a subset of logging, or do you all think no, that is a different kind of thing, that is instrumentation, that is performance monitoring, that is nothing to do with logging?
It depends upon the team's, actually, the engineer's role, naturally, because as my role, I do consider the metrics and this I normally use the metric beats from Elasticsearch to take these matrices and check the performance, because in Kubernetes environment these are very important things: how many pods are getting consumed, what is the scalability of the systems and everything. But I also have seen team members when I was very young in the, I don't bother about these things. For me, whether the transformation does the job which it needs to do again and again, the immutability works perfectly. That time I was concentrated on those logs, but as I gained more experience, I started into the performance and the infrastructure side loggings of the pipeline.
Others has any opposition view on this? Do you think it is important, is it unimportant?
So these two are important. So there is one more thing is sort of creating a checkpointing, not just the logging. So when you talk about logging, so with the logging, you should also create some sort of checkpoint so that let's suppose something happens in your pipeline, let's suppose something fails. So from there, it should be able to go to that point. So that is one. So in the earlier organization, what I did is, so, when we moved the Delta Lake, so at every stage, what I used to do is, okay, so this is my important stage. Now, if something fails for the next stage, then it will take a huge time to come to the stage again, and writing the data again and again into Delta Lake takes a lot of time because it is an unnecessary merge. Okay. So that's where I use that sort of thing. So it's basically doing a checkpoint. Okay. And also that checkpointing is sort of acting as my logging. So basically, I created a dashboard from that. Okay, so what is happening from that I can see what is happening to my system. So the basic purpose is what is happening to my system. The first thing I need to check that, and in that I also used to bring in what is the time it took and what are the number of columns it changed and all the stuff, so that at later point I can check what is happening and what is not happening. So there's one way, and the other way is the normal logging. So that is also there. But I emphasize this thing much larger because I'm responsible for the end-to-end pipeline. So what is happening to my pipeline, monitoring that is the first thing, and then I can go into the deep or a small point of what is happening to my system at a later stage.
Okay, good. So, okay, so I think, of course, obviously, we crossed all the time, and I realized there are few things on this before we all see off. And the questions, I think we still have many points. Like we have more topics in mind. We have many small topics to cover as well. So I will suggest please add those sheet, and if it is required, we can do more frequent meetings to at least address and try to bring address more and more questions and try to even learn ourselves. So these sessions, it is very important for me as well. I'm learning too many new things, and I'm trying to understand, okay, I never thought about this. It comes way before this. Like, how will I explain this to any junior who is joining us? So that is the same thing we need to care. So please ask your questions, and next time we will address the fresher question, which was actually the second question today. Thank you all for your time, and hope to see you soon. And let's go back to the questions whenever you have, add to that doc, and we will try to prioritize all those questions. Thank you all for joining.
Yeah.
Thank you guys. See you all next week.
Bye bye.
Bye bye.
Bye.